The objective of this video is to explain the basic outlines of how to complete an inclined plane lab. Here we have 5 steps that we need to follow. The materials we need to complete this lab is the physics lab inclined plane and a set of 5 weights with different masses. We are going to start by placing a weight on the board and lift the board slowly and steady, and when the weight barely starts sliding from the top of the ramp, record the angle marked on the protractor in this table. Now we are going to convert the mass from grams to kilograms and then calculate the weight in Newton following this example. So for these 100,000 grams divided by 1,000, we have the mass in kilos. To calculate the weight, just multiply the mass in kilos times 9.8 meters per second square. Now we have the weight of this mass converted to 9.8 newtons. Repeat this process for every single mass. Now we are going to draw the inclined plane free body diagram. We are going to represent the weight by this box and place at the middle way of this plane to facilitate our drawing. First, draw the weight force from the center of mass of this box, and from the tip of this vector, draw a fine line and find the components. Here is the X component of this weight, and here we have the Y component of this weight. This angle is the same angle of this ramp. To complete this free body diagram, here we have our friction force that opposes the motion, and here we have our normal force, which is the normal of the contact surface. To find the components, we are going to temporarily move the FGX to the bottom of this right triangle. Since FGX is the opposite of 30 degrees, we are using sine. And FGX is adjacent to 30 degrees, we are using cosine. Now we are going to complete this table and find the components for each weight. So let's use sine and cosine to find the components. And let's start with the first weight that we have, 9.8. And then we are going to use our minimal angle to calculate the component for this weight, for the first one. So 9.8 newtons, the FGX will be 9.8 times sine of 12 degrees, which is 2.03 newtons. And this is actually is FGY, is 9.8 times cosine of 12 degrees, which is 9.58 newtons. To complete this table, we are going to assume the system in equilibrium, which means that FF is equal to FGX and Fn is equal to FGY. There is a type of mistake here, but this is FGY. So now we are going to replace these values on the first row. 2.03 is our FF because it's equal to FGX. And our Fn is equal to our FGY, which is 9.58 newtons. To find the coefficient of friction, we divide the force of friction by the normal force. We cancel those units, and the coefficient of friction for our first weight is 0.212. Now, for this column, we are going to calculate the tangent for this minimal angle. So the tangent of 12 is 0.212. Very similar, but why? So that's part of your lab is to complete this question. So we have just basic 3 questions. So which force caused the weight to slide? So you just need to look at this diagram. The second question is, the calculated coefficient of friction is a static or kinetic friction? And the last one, when we compare mu with the tangent, what we can conclude of this relationship? And I want that you prove why. So I hope this explanation help you on how to complete this lab.